Okay, this question says that the complex number u and w satisfy the equation u minus w is equals to 4 iota and uw is equals to 5. Solve the equation for u and w, giving all your answer in the form of x plus iota y, where x and y are real. All right, so now we need to take a moment and look at the information given to us. They're two complex numbers. Let's call them u is equals to, let's say, a plus iota b, and w is equals to c plus iota d. Now, what is this telling us? U minus w is equals to 4i. That means there is no real part left when you subtract them, which means that the real parts are equal. Hence, when you subtract them, they get eliminated. They become 0. So this will be a as well. Then we look over here. It says that the product is equals to a real number as well. That happens when the numbers are complex conjugates of each other. And again, the imaginary part cancels out after multiplication. So that means that W is going to be the conjugate of U. So W will be U conjugate and it will be equals to A minus iota B. All right. Now we need to find the value of U and W. Okay, so we will add them and equate it to 4i. Sorry, we'll subtract them and equate it to 4i. So when we subtract them, the sign will change, minus and plus. So we get 2b iota is equals to 4 iota. So b is equals to 2. Okay. Next, we multiply them and equate it to 5. So a plus iota b times a minus iota b is equals to 5, which is giving us a squared minus ab iota plus ab iota minus iota b whole squared equals 5. Iota b whole square becomes minus b. So this would become minus b, and there's a minus outside, so it will become plus b squared. This and this cancels out. So a squared plus b squared is equals to 5. A squared plus 4 equals 5. A squared equals 1. So a equals plus minus 1, which means if u is 1 plus 2 iota, then u conjugate or w would be 1 minus 2 iota. But if we take minus 1 plus 2 iota, because a can be minus 1 as well, then u conjugate or w will be minus 1 minus 2 iota. So these are the two possible sets of answers. Okay. On the sketch of an Argand diagram, shade the region whose points represent complex number, satisfying this with an argument of this and a real part greater than equals to z, where real of z denotes the real part of z. All right, now we draw an Argand diagram. The first inequality is a circle whose center would be, change the signs, 2 comma minus 2. So this should be a circle with the center of 2 comma minus 2 and a radius of 2. Let's start with that. So we'll write real z and imaginary z, and we need 2 comma negative 2, so 1. 2 scaling should be approximately same on the x and y axis. This would be 2 comma minus 2. Okay. And now we need to draw a circle around it with the radius of 2. So it's going to be tangent to the x and y axis. Something like this. Okay. So this is the circle. Okay. We need to shade inside the circle, but not yet because there are more inequalities to look at. Okay. Next inequality is z is less than equals to, argument of z is less than and equals to minus pi by 4. Let's make the angle minus pi by 4. It's going to exactly pass through the origin in the center. Okay. And now z is less than and equals to this angle. That means it has to be here because it's negative. So you will be shading the part with the greater magnitude. Okay. And the third inequality we need to look at is real part of z is greater than equals to 1. That is going to be this line, and we will be shading right of this line. So this inside the circle, underneath the angle line, and towards the right of z is equals to 1. All these lines would be solid lines because it's less than and equals to with all three of them and not just less than. Okay. Part B1 is done. Now B2 says calculate the greatest possible value of real z for the points lying in the shaded region. Okay. So the greatest possible value of real of z would be this in the shaded region. We need to define this value on the x-axis here or on the real axis. Okay, so how can we do that? We know that this angle is also pi by 4 or negative pi by 4. Okay, then we should be able to find this length. How do we do that? We know the radius is 2. So this part is going to be 2. This part from here to here, it's going to be 2. And we will use distance formula between the point 2 comma negative 2 and 0 comma 0 to get the remaining distance. Let's apply the distance formula on 2 comma minus 2 and 0 comma 0. That's just y2 minus y1 whole square plus x2 minus x1 whole square. We could have just applied Pythagoras theorem here as well, because this is the center, this is 0, 0, and this is 2 units, and this is 2 units. So square root of 2 square plus 2 square. So square root of 8 or 2 square root of 2. So this length is 2 square root of 2 from here to here, and from here to here it's 2. So the full length of this triangle, it would be 2 square root of 2 plus 2. And this is pi by 4, we're ignoring the sign. And this is a 90-degree angle, and I need this length. That will give me the greatest real value on the shaded region. So we will use cos. So cos pi by 4 is equals to adjacent over hypotenuse. When this is solved, we get 2 plus under root 2. So this would be the answer.